Number 4 was kind of challenging, especially the amount of room that I left for you. So let's go through it. The drawing below is a floor plan, so we're looking at a blueprint. Basically, this is the hallway. These things represent doors. So if you don't know that yet, maybe you want to make a note of this door. All right, we have a window, a heating duct. Heating duct means where the heat comes from. It's a heat vent, okay? And finally, we are talking about thermostats. So a thermostat for the heating system, it tells you here, it controls the temperature in this large room. And 4 possible places or locations are shown in the plan. Explain why each, and we're explaining, so I want to make sure that we use the nerd, why each of the locations is either good or not good for the thermostat. Where would we place it? That's basically the goal of this question. Include the heat transfer methods, okay? So that's conduction, convection, radiation for each location in your answer. That is a part of the explain, all right? So it's asking you to please use the information that you have in order to use what you know to show why each one of those heat transfer methods is either good or bad, the locations are good or bad based on heat transfer. In number 1, it's directly inside of the door. I'm not sure about that yet, so let's take a look at a couple other things. Number 4 is outside of the room. It's very hard to control the temperature of a room from outside of the room, so that is actually not good. And that's because it's outside of the room. And what that means, it doesn't have an accurate measurement. No accurate of the temperature. Can you see that? Of temp. All right, and there's really no heat transfer method happening. I'm sure it's, it can be convection through the air or conduction through the wall, but I don't think that's going to make that big of a difference. You don't want to place a thermostat for a room outside of the room. That just doesn't make any sense. Let's take a look here at number 2. 2 is right next to the heating duct, which means that all of the heat is blowing directly on it. So as soon as this turns on, it probably turns itself off before the heat has the opportunity to convex through the rest of the room and heat up the room. So this means that putting it here is not a good location either, because the convection isn't going to heat the entire room. It's just going to blow on this and then immediately turn off the heat. All right, so the rest of the room is not going to have the opportunity to get heated up before the thermostat turns off the heating system. Does not allow heat to convect around the room to warm it before it turns off. Okay, let's look at number 3. Number 3 is right next to the window. If you put a thermostat right next to the window, conduction is going to happen when it's very cold out. All right, it'll go from the cooler outside into the warmer inside. I'm sorry, the heat from inside is going to go this way. Ooh, sorry. It's going to go from the warmer inside straight out through the window to the cooler outside when it's very cold out. And then what happens is you are turning the heat on a lot because you don't have an accurate measurement since you're conducting right next to this window. So number 3 is also not good because heat conducts out. The window. All right, and it will keep turning it on, but that's going to be probably really bad for the heating energy because it's going to keep the heat on a lot more than it should be. That said, number 1 is really the only good place for it because it's not next to a convecting heat duct or a conducting window, or it's not outside of the room itself. No conduction from window, convection from the heat vent, and it's in the room. Okay, So each one of these is going to be worth 1 point. And I know this was kind of a long question, but it's important that you have an understanding. That's another 4 points.